As we think about carbon being this organic molecule of life, there's an atom on an element. You'll hear me call them atom, element, element, atom. There's one that kind of sits up here all by itself. Hydrogen. And that one is number one. In the structure of hydrogen, I've got my nucleus, I've got one outer shell, and that outer shell only contains one electron. One electron. How many does it need to be happy? Needs one more, but that means two. So 2 electrons will make it happy. Well, here we go. Carbon, meet hydrogen, hydrogen, meet carbon. You're just what I need. You're perfect. Because guess what? Hydrogen will come in, hydrogen will come in, hydrogen will come in, hydrogen will come in. Now, how many electrons do I have in that outer shell? 8. It's now happy. And it made methane gas. What other types of gases do we have? Ethane, butane, propane, octane. Is everybody following me? Guess what they're combinations of? Hydrogens and carbons and a lot of other stuff that I don't like to think about. Now, let me think about something else that I've mentioned. Glucose. Wow. Glucose. Anybody know the molecular formula for glucose?
C6H12O6.
C6H12O6. What did I say earlier about the glucose molecule? It's the smallest molecule that the body uses. It cannot be broken down any further. It is the molecule we need. All right? Now, depending on how you consume it is the difference. Okay? Me, I'd much rather consume it in a donut. All right? Just saying. Now, C6H12. This is what's termed the carbon-hydrogen backbone. What other types of molecules do we need for life? Sugars? Well, let's think of food we eat.
Carbs.
Which is our sugars? Huh? Lipids? Think of foods that we are going to eat, that are molecules that we need. My sugars, my fats, my proteins. Sugar, we've just determined, is a carbon-hydrogen backbone. Lipids, guess what? Carbon-hydrogen backbone. Proteins, guess what? Carbon-hydrogen backbone. Isn't that kind of cool? Here we are, this carbon organism, taking in carbon stuff. The way that it's going to become important, what is going to happen with these electrons in the outer shell? Because when we look at what happens with our elements, okay, that are going to combine to form molecules, to form compounds, to begin to form parts of the cell. When we begin to look at how they're going to react, okay, we are going to have to pay attention to those electrons. Now, when we talk about an element on the periodic table, I've mentioned carbon-6 because we understand that the elements that are listed on the periodic table, they are simply an average that exists. Okay? For example, carbon, when we look at carbon, there is a carbon 12, there's a carbon 14, there's actually a carbon 13. Have you heard of any of those? How? With what?
Carbon dating.
Carbon dating. Do you know which one's used?
14.
14. Now, could I be made of carbon 14? No. Why? It's radioactive. Aren't there a couple of songs about being radioactive? Yeah. I know there's like one from when I grew up. Trust me, that's a long time ago. But isn't there one like lately that's been radioactive? Sing that. I can't remember. Imagine Dragons. See, I knew that. All right. So now, if I begin to look at this, what changed? I'm still carbon-6, but now my 14. These subatomic particles, what changed? My neutrons. My neutrons became what? 14 minus 6, 8. What did that do to my atom down here? It made my nucleus heavier. Did it do anything to my structure for the electrons? No. However, that is now radioactive. We don't need that. This is called an isotope. When you change the number of neutrons, this is now an isotope. For the most part, isotopes are radioactive. But that's not a bad thing. Well, okay, wait a minute. Whoa, time out. Hold up. It's not always a bad thing. Okay? I mean, there's a whole area of study, the radioactive imaging, okay? Radioactive scans, all right? And they're very beneficial. You're injected with some radioactive material. They put you in a room by yourself because, hey, you're radioactive. You don't need to be around anybody else, okay? Somebody will come in a little bit later, do the scan, leave, and they tell you to go home and not get around anybody pregnant. Because you can make them miscarry. Because you're radioactive. But guess what? It's going to leave in just a little while. About 24, 48 hours, you won't be radioactive no more. It's pretty cool, right? I think so. Yeah, I've had one. It's cool. So, whenever we change the neutron number, whenever we change the mass number, we're going to create something that most likely is radioactive. but it doesn't necessarily have to be something that is bad. We utilize a lot of this radioactivity in the imaging that we do. For example, the PET scan, that radioactive labeled glucose, which I think is just so cool. But that's just me. We can use this radioactive material to treat cancer. Huge topic. Sterilize utensils that are used in surgery. So the radioactivity, now, when it becomes something that is bad, for example, y'all are probably too young to remember this one. Oh, hey, okay, no, y'all not too young to know about the latest huge radioactive, disaster that we had over in Japan, right? Okay, and all the radioactivity that's like leaking into, we got exposed to it here in the U.S. The whole world got exposed to it, okay? Just not as heavily, okay? All the radioactivity that's leaking into the ocean. You think you're going to be immune to that? No, you're not, because it's making its way through all of the currents of the ocean. So it's going to eventually make its way here. Just when is the question. Here's the problem when we have an incident or something like that. When we look at these radioactive to produce the energy, the radioactive they produce the energy that we use when we turn on the lights and stuff. I just can't remember the name of it right now. It totally went out of my head. Materials get released that are radioactive. For example, iodine. Now, any idea how iodine might be used in the body? Our thyroid. Here's the problem with our bodies when exposed to radioactivity. The body cannot determine if the material is radioactive or not. It will take it up. So if it takes up the radioactive iodine, well, guess what? That's radioactivity to the areas of the body that absorb it. Something else that gets released in times of these radioactive disasters, strontium. That gets taken up by the bone, kills the bone. So there are different things that happen. Reactors.
Glad I can help.
There you go.
Don't we also use a different type of iodine to treat radioactivity? Can they give iodine pills?
Now, what they can do, like say for example, if someone has a thyroid disorder, they used to go in and surgically remove the thyroid. But see, the problem is, on the back of the thyroid are these 4 little glands that are extremely important, called the parathyroid glands. They would also often get removed at the same time. There was nothing they could do to help the person. The person died. So now, people who have an issue with their thyroid gland, they can give them a little radioactive pill that can go in and just kill the tissue. And then they can be on a thyroid medication. And it's fine. There's usually no problems. So my dad has one of them with the thyroid. I can't remember what it is. Hey, it took me a while to get reactor. So, okay, yeah, that'll be my cue. So radioactivity